In this video, we are going to be looking at sequence and series. A sequence is a group of numbers that follow a repeated pattern. Or you can say a sequence is a group of numbers that follow, that obey a particular formula, or that, have the same formula. Now we see some questions here that has to do with sequence. It says, write out the first 5 terms of the sequence represented by, we have 3 questions there. Now let's start with the first one. We are given that Tn is 3n plus 3n minus 1, okay? So if you have to find T1, it means that your n is 1. That will be 3 times 1 minus 1. That's going to give us 2. T2 here means 3 times 2 minus 1. That's going to give us 5. T3 means 3 times 3 minus 1. That's going to be 8. T4 is 3 times 4 minus 1. That's going to give us 11. Then T5 is equal to 3 times 5 minus 1. That's going to give us 14. So for the first guy there, the first 5 terms of that sequence is 2, 5, 8, 11, and 14. So that's the answer to the first question. Now the second question, we ask 2 raised to power n plus 3 raised to power n. That means T1 will be 2 raised to power 1 plus 3 raised to power 1. That means 2 plus 3, which is 5, okay? T2 means 2 raised to power 2 plus 3 raised to power 2. Your n is 2 now. That will be 4 plus 9, which is 13. Your T3 now is 2 raised to power 3 plus 3 raised to power 3. That means 8 plus 27. That will give us 35. Then your T4 is 2 raised to power 4 plus 3 raised to power 4. That's going to be 16 plus 81. And that is 97. Then T5 now is 2 raised to power 5 plus 3 raised to power 5. Okay, that's going to be 32 plus 2, 43. And that is 275. Okay, so it means that the first 5 terms here of this sequence is 5, 13, 35, 97, and 275, and 275. Okay, so that leads us to the third question. We have 2 raised to power 2n into n plus 1. Okay, so if when n is 1, the first term here, that's T1, will be equal to 2 raised to power 2 into 1 plus 1. That's 4 times 2, which is 8. Your T2 is going to be 2 raised to power 4. Then 2 plus 1. Okay, so 2 raised to power 4 is 8. Okay, times 2 times 1. 8 times 2 is 16. So you have your T3, which means 2 raised to power 2n, that's 2 times 3 is 6, okay, into 3 plus 1, okay. That is going to give us 2 raised to power 6 is 64. So 64 times 4, that is going to give us 256. You continue that way, you can go ahead to find T4 and T5. Okay, so that means the sequence here is 8, 6, 2, 5, 6, and so on and so forth. Okay, now that leads us to series. A series is the sum of a sequence, which can be represented by the symbol summation Tn equal to Sn. Okay, that is what a series is, the sum of a sequence. And so if we have this as a sequence, 2, 5, 8, 11, 14. If you have this as a sequence, it means that the series will be written 2 plus 5 plus 8 plus 11 plus 14, okay? According to definition, that's the definition for the series. Okay, so we see a question here. We ask to evaluate the following. Now you can see the summation sign, and you can see here you have I equal to 1, and that means your I must start with 1 and then end with 5. Up here is 5, okay? That's what it means. So your I starts with 1 and ends with 5. So summation of xi actually means x1. That means when I is 1 plus x2 plus x3 plus x4 then plus x5, okay? There's nothing else we can do there. Now that's the answer to that question. So we go to the second question here. So we are given 1 over 2, summation of 1 over 2 raised to power x. So your x should start with 0 and your x should end with 3. Okay, so with that we are going to have 1 over 2 raised to power 0. Now plus 1 over 2 raised to power 1 plus 1 over 2 raised to power 2 plus 1 over 2 raised to power 3. Okay, so 1 over 2 raised to power 0 is 1. Plus 1 over 2, that's 1 over 2, plus this is 1 over 4, and plus this is 1 over 8. We can as well find the LCM, which is 8. Okay, that will give us 8 here, plus 2 in 8 is 4. 4 times 1, 4, plus 4 in 8 is 2, 2 times 1, 2, plus 8 in 8 is 1, 1 times 1, 1. So that gives us 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. So the answer to that question is 15 all over 8. That's quite easy, okay? So that leads us to the next question here. Here we are looking for summation of x, okay? But your x must start with 2 and end with 6. So that means you're going to have 2x2 when x is 2. So plus 3 plus 4 plus 5 plus 6. That's the series. 2 plus 4, 5 plus 4, 9 plus 5, 14, 14 plus 6 is 20. So the answer to that question is 20. Okay, that's good enough. Now the last question here, we are asked to find the summation of 1 over r into r plus 1, but your r must start with 0 and end with 2. Okay, so when r is 0, we are going to get 1 over 0 into 0 plus 1. Of course, this is going to be indeterminate because any number over 0 is indeterminate. So let's change the question. Let's say r starts with 1, okay? So for r to start with 1, it means you're going to have 1 over 1 into 1 plus 1. Then plus, when r is 2, it becomes 1 over 2 into 2 plus 1, okay? So that gives us 1 over 2 plus 1 over, this is 6. The LCM here is 6, so we have 3 plus 1, and 3 plus 1 is 4, so that gives us 4 over 6. And 4 over 6 is the same thing as 2 over 3. Okay, so that gives us the answer to that question. Now we see the next thing here, which is arithmetic progression. An arithmetic progression, AP, with the short form AP, is a sequence in which each successive member differ by a common difference. So if you see the members of an AP, there is a common difference. Just like you see here, 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is also 3, okay? So the same thing here, that means here the common difference here is 3. For this one here, you can see that the common difference already, the common difference here is 2 because the difference is 2. Then here, the common difference here is minus 4. That means each term differ by the other by minus 4. So that's an AP. Whenever you see a sequence that differ by a common difference is an AP. So that leads us to this. Here, we are asked to